Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 9, Decimal Expansion of Fractions, Part 1. Classwork, opening exercise. Compute the decimal expansion of 5 over 6. So to compute a decimal expansion, you can do long division. And 6 will not go into 5, but 6 will go into 50. 8 times. 6 times 8 is 48. Subtract and get 2. Bring down a 0. 6 goes into 23 times. 18. And as you can see, it's going to be 2 over and over and over. So it's 0.83333 ... forever and ever. 7 divided by 9. There's a trick with the denominator of 9. The answer on that, I'm going to save time by not doing long division. You can check it on your own, but when you take anything divided by 9, that's one digit anyway, the numerator is what gets repeated. So this is 0.777 repeated. Okay, number 2, or part B. What is 6 plus 7/9 as a fraction? So when we add fractions, the denominators have to be equivalent. Okay, so 6 and 9, least common multiples of 6 and 9 are 18. 6 times 3 is 18. So if I multiply 6 by 3, I have to multiply 5 by 3 and get 15. So 5 6 is 15/18. 9 will go into 18 2 times, so 7 times 2 is 14. So this is equivalent to 29 over 18. So if I now take 18, let's move this up. And if I take 29 and divide by 18, I get 11. And 18 will go into 110 6 times. Here, let me fix this. I'll be mindful of my decimal. So 18 will go into 29 once. The decimal's here. 6. 6 times 8 is 48. 6 plus 4 is 10, leaving me with a 1 here. 1 goes into 18, or 18 goes into 20 one time. So subtract, and that's going to repeat now. 1, 1, 1, 1, 1. So this 5 6 plus 7/9 is 1.6111, repeating forever and ever and ever. If we go up to our part A and take 0.83 repeating and take 0.7 repeating, then 8 plus 7 is 15. So I get a 1 here. And then 7 plus 3 is 10, so you carry the 1 and get a 6. So it's just like adding the expansion. So you're going to get 7 plus 3, which is 10, carry the 1 every time, and we're going to get 1, 1, 1, 1, 1. Part C. What is 5 over 6 times 7 over 9 as a fraction? Remember, when we're multiplying, denominators do not have to be the same. You just multiply the numerator, 5 times 7, and 6 times 9. And if I take 54 and divide 35 by it, 54 will go into 356 times. 6 times 4 is 24, carry the 2. 6 times 5 is 30, plus 2 is 32. Subtract, and that will be 6 to bring down a 0. 54 will go into 26 4 times. Or 54 will go into 264 times. 4 times 4 is 16, 21. Subtract, and we get 10 minus 6 is 4, and 5 minus 1 is 4. and 54 will not go into 44. Did I do that right? Well, I bring down a 0. Six times 4 is 24. I just didn't line it up right. This should be over further. So bring down a 0, and 54 will go into 440 8 times. 8 times 4 is 32. 5 times 4 is 20, plus the 3 is 23, and we get 8, 0. And so that's 1. So it's 0.6481. 481, 481 is going to keep repeating now. So those keep repeating after the 6. Okay? All right, so a little bit of practice with computing two fractions, then adding them and seeing what their product is, or their sum is, and then multiplying them and seeing what their product is. 8 times 7 is, 7 times 8 is 56, so let's see. 64. Interesting. All right, so D. If you were given just the decimal expansion of 5, 6, and 7/9 without knowing which fraction produced them, do you think you could easily add the two decimals to find the decimal expansion of their sum? And then could you easily multiply the two decimals to find the decimal expansion of their product? Okay, so to answer these questions, the first question, is it easy to add them? And the answer is no. To add 0.83 repeating and 0.7 repeating, we need to start by adding together their rightmost digits. But these decimals are infinitely long and there are no rightmost digits. It's not clear how we can start the addition. Okay, where do we start? Third, fourth, fifth? We can't. Okay, because we have to carry over to the next digit. And then thinking about how to multiply two decimals, 0.83 repeating and 0.7 repeating, is even more confusing. So in decimal form is very difficult. So exercise 1, parts A and B, say two irrational numbers x and y have infinite decimal expansions that begin 0.67 for x and 0.84 for y. A says to explain why 0.670 is an approximation for x with an error of less than 1,000th, and explain why 0.849 is an approximation for y with an error of less than 1,000th. Okay, so the reason is, or the explanation is, the difference between 0.670 and 0.6703527 is 0.0003527, which is less than 0.001, which is 1,000th. Okay, it's actually 3/10,000ths. And the difference between 0.849 and 0.8499141 is 0.00091341, which is less than 0.001. It's 9/1000ths, or 9/10,000ths, which is less than 1/1000th. Okay, part B says, using approximations given in part A, what is the approximate value for x plus y, x times y, and x squared plus y, and 7y squared? Okay. So, using approximations for x plus y. So, x plus y. So, up here the approximation is, this is x, and this is y. So we're just going to substitute those in. So x is 0.670, and we're going to add, and I'll do it vertically, it's just easier, and y is 0.849. And when I add those, I get 9, 1, 6, 1.619. Okay, let's fix that. 8 plus 6 is 14, plus 1 is 15. So I need to change this to a 5. So it's 1.519. Now when we do x times y, it's going to be 0. Here, let me do it vertically again. It's going to be 0.670 times 0.849. Okay, so whenever I multiply, I would actually move this around like so. I'd put the 0.849 first and put the 0.670 underneath. Because of that 0, there's less to multiply, so I just bring that down. 9 times 7 is 63. 7 times 4 is 28, plus 6 is 34. Carry the 3. 56 plus 3 is 59. Okay. 9 times 6 is 54. 6 times 4 is 24, plus 5 is 29. 6 times 8 is 48, plus 2 is 50. 0, 3, 8, 8, 6, 5. And there's 1, 2, 3, 4, 5, 6 decimal places. Where would the decimal go? 1, 2, 3, 4, 5, 6, and it's 0.568830. Now when we do x squared plus 7y squared, it would be 0.67 squared plus 7 times 0.849 squared. Okay, so I'm going to ask Siri for help here. Hey Siri, what's 0.67 squared?
0.67 raised to the second power is 0.4489.
Hey Siri, what's 0.849 squared?
0.849 raised to the second power is 0.720801.
Okay, so I'm going to have 0.4489 plus 7 times 1 is 7, 7 times 0 is 0, 7 times 8 is 56, the 5 carries, 7 times 2 is 14, 7 times 7 is 49, plus 1 is 50. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 7 times 0.72 is 5.045607. Okay, getting closer. So when I add these, I'll just bring this piece, just to save time, I'll bring this over here and line it up like so, and get rid of this plus sign, and add these. So it's 7, 0, 5, 4, 9, 4, 5. So it's 0.5494507. Okay, so we added them, we multiplied them, we squared the first, and we took 7 times the square of the second and added them. C says to repeat part B, but use approximations for x and y that have errors less than 1 over 10 to the 5th, which is 10th, 100th, 1000th, 10,000th, 100,000th. So we want errors less than 100,000th. So our error is going to be less than that. If we approximate x by truncating to 5 decimal places, okay, so if we approximate x to truncate by 5 decimal places is what that means. So if I come up here, here's x, and there's 1, 2, 3, 4, 5 decimal places is 0.67035. So it's x is 0.67035. So our error is going to be less than this. Okay? And then y truncated out to 5 decimal places will be come back up to y, 1, 2, 3, 4, 5, it's going to be 0.84991. Okay, so now that we've done that, now we are going to repeat b. So x plus y, I'll put here, and that's going to be 0.67035 plus 0.84, whoops, 0.84991, and that's going to give me 6, 2, 0, 2, 5, 1. X times y is going to be 0.67035 times 0.84. Oh, me and my fours, that keeps snapping. Alright, I gotta write them slower. Do this, wait a second, do that. 991. Okay, I'm going to calculate this off to the side, and I'll just save time. This is going to equal 0.569737 1685. Now we're going to take x squared, which is 0.6735 squared plus 7 times 0.84991 squared. Plug that into a calculator and we get 5.50798,179. Okay, so what did that do? How much did that change if we truncated? Here's our answer with the truncation compared to, is that actual? No, we truncated out further. So this is 0.670, and then we went out, instead of 3 decimal places, we went out 5. So this will be more accurate, but it's close to that. Here's a more accurate representation of this approximation, and this is a more accurate result of that approximation. So they're still pretty close. This is 4/100ths off. This one is 1/1000th off, and this is 1/100th off. Okay, exercise 2. Two real numbers have decimal expansions that begin with the following. Using approximations for x and y that are accurate within a measure of 1/10 cubed, find approximate values for x plus y and y minus 2x. So when they're saying 10 to the third, that's how many decimal places we're going to truncate, which is here. Now, do I round that up to 4 and round that up to 8? Okay, so when we're approximating out to decimal places like this, we do not round up or down. We just cut it off, and that is it. So x plus y would be 0.153 plus 0.307, and I get 0.64. So 0.460. Okay, when I take y, which is 0.307, I'm going to subtract 2 times x. So off to the side here, I'm going to take 0.153 times 2 and get 0.306, and I get 0.001. Okay, part B, using approximations for x and y that are accurate within the measure of 1/10 to the 7th. So now I need to move this There's 1, 2, 3, 4, 5, 6, 7. That's using the whole number. Now we're going to do the same thing. X plus y. 0.1538461 plus 0.3076923 will give me 4, 8, 3, 5, 1, 6, 4. And now I do this one, y, which is 0.3076923. And off to the side here, I'm going to take that 0.1538461 and multiply it by 2. And I'm going to get 2, 12, 9, 16, 7, 10, 3. So I'm now going to subtract 0.3076922, and that's going to give me 0.0000001. Okay, notice what happened here. This is 1/1000th, and this is 1/10,000,000th. Okay, C says we now reveal that x equals 2/13 and y is 4/13. How accurate is your approximate value to y minus 2x from part A and from part B? So now if I take y, 4/13 minus 2 of these, which is 4/13, okay, 2 over 13 times 2 over 1 is 4 over 13. Alrighty. So what do I get? 0. How accurate is our approximation? That's pretty close. 1/10,000,000ths is pretty close to 0. Okay. Part D now says to compute the first 7 decimal places of 6/13. So that's taking 6 and dividing by 13. So I'm going to put a 0. And I'm going to save time here. We don't need to do long division. Hey Siri, what's 6 divided by 13?
6 divided by 13 is about 0.4615.
Okay, she didn't go out far enough. So let me use my calculator. Okay, so using a calculator and going out 7 decimal places, it's 0.4615384. Okay, before I do that, why did we do that? Going out 7 decimal places, we got the same answer. So it's very close. Okay, so that is the end of lesson 9. Review the lesson summary and go do your problem set.